problem cutting across the great conversation that's occurring, so my apologies, but I'm sure you're looking forward to the main event. I'm Susan Elliott, and I'm very pleased to welcome you all to the third and final event of our 2023 three-part series on the global challenges of the age. As I begin, I wish to acknowledge the Wurundjeri people as the traditional owners of the land on which we meet today, and also the traditional custodians of the various lands on which you may be joining us for those attending virtually. I pay my respects to their elders past, present and emerging, and extend those respects to all Aboriginal and Torres Strait Islander persons present today. Tonight, we are delighted to welcome current and former members of Monash University Council and more than 1,200 alumni, donor, students, staff and friends of the university from 37 countries around the world, both here in person and online. It's wonderful to see so many of you at an event which allows us to reconnect with members of our alumni and donor community, as well as with industry and government representatives, and to engage with you on the work we are doing and the ambitions of our strategic plan, Impact 2030. Thank you all for joining us. We're extremely proud of our global alumni community, which now spans over 470,000 people across more than 150 countries. We're equally proud of your achievements and contributions and the positive difference you're making to the world through your careers, the industries in which you work, and the communities in which you live. I'd also like to take this opportunity to acknowledge the Monash donor community who are here tonight. Our philanthropic campaign, Change It for Future Generations, is a collective endeavour and represents a shared vision between Monash and our philanthropic partners to push the boundaries and transform our world for the better. I know some of you here tonight will have attended either one or both of the previous sessions of this series, which focused on climate change and geopolitical security. But for those of you who are here for the first time, allow me to share with you a brief overview of Impact 2030, our strategic plan. Impact 2030 is a plan of action for the next decade, and it's a plan with a strong focus on Monash addressing three of the most significant global challenges of our time: climate change, geopolitical security, and the theme for tonight's event, ensuring thriving communities. The plan charts the path for how Monash will actively contribute to addressing these challenges through its research and education, and in collaboration with government, industry, alumni, donors and community. It's a plan about how Monash may work in and with communities for a better future for all. Importantly, Impact 2030 begins with a strong commitment to Indigenous peoples, knowledges and cultures. It also outlines our 4 strategic goals: to be excellent, international, enterprising and inclusive, which were built from the Monash's culture and values as they've developed since our very beginnings in the 1960s. These goals have been redefined for the next decade to support the university's response to climate change, preserving geopolitical security and fostering thriving communities. And so, following on the first 2 sessions on climate change in May and geopolitical security in August, we now turn our attention to thriving communities, with tonight's discussion focusing on the question: how do we harness AI and other emerging technologies for good? To moderate this discussion, we're very fortunate to have with us here Natasha Mitchell, a Monash alum, multi-award-winning journalist, radio presenter, podcaster and documentary maker. And joining Natasha are 3 esteemed panellists: Professor Jeff Webb, who'll join us online, Professor Patrick Kwan, and Associate Professor Michelle Lazarus, to share their insights. Let me take this opportunity to express my sincere thanks and appreciation to Natasha and to our panellists for your time and expertise. We look forward to hearing your thoughts. Thriving communities holds the promise of the good life we seek. It's the challenge of how we live well and how we live well together. Problems we face include medical, health, and technological issues about the family, individuals and population, the burden of disease, and systemic social issues of inequality and disadvantage, intolerance, discrimination and violence. The challenge of creating thriving communities requires transformative responses built not for but with communities locally, nationally and internationally. As a university, we must contribute to better understanding as well as creative and innovative solutions. And we must develop research and education that creates new responses, behaviours and practices. Proudly, Monash is already doing a great deal of work in this space through our teaching and learning and through our research. I trust that you will enjoy the discussions that follow, and I thank you again for joining us to tonight's event. I'm now pleased to introduce our moderator for this evening, Natasha Mitchell. Thank you, Natasha.
Thank you, Vice-Chancellor. And hello this evening. Let's bring our wonderful panellists onto the stage, and we've got Jeff Webb joining us online. And hello to hundreds of you joining us online from all over the world. 1,200 total booked for this event in 37 countries. Isn't that phenomenal? What an amazing alumni community we have. And as a Monash alumni, in my case of engineering, I'm very proud and delighted to be here in Naarm, Melbourne, here at the Edge Theatre. And I also want to acknowledge, relevant to our discussion tonight, the incredible scholarship of First Nations technologists and scholars in Australia and worldwide who are really interrogating artificial intelligence and what it means from a First Nations perspective, and I really commend their work to you. It's a growing movement of great interest. Now, before I introduce our excellent speakers in a little bit more detail, we thought we'd try an online poll, and in the room it's going to be fully embodied, nothing artificial or artificially intelligent about it. Online, we would love you to respond to this question, and in the room, I'm going to get you to do it by a show of hands. So, to what extent do you think AI can be used as a force for good? Answer 1, very likely, possibly, no way. Oh, excellent. The outlier in the audience, we might need you up on the panel. And the online audience is doing the same. So I'll look forward to seeing your responses as well. And of course, there's a great chat facility online as well, so you can talk amongst yourselves about some of the issues coming up. Look, AI is certainly everywhere. We know that, and exponentially so now. It's in the algorithms that feed your Google search results. It's in the ads on social media, the algorithms that drive that. It's in the algorithms that give you song recommendations on Spotify. It's in autonomous vehicles. It's driving generative AI chatbots like ChatGPT. The thing is, it's been around for decades. But it now is certainly fueling an anxious and heightened conversation, I think, about biased algorithms that have the potential to discriminate against us on the basis of our race or our gender or our demographic, in the threat that it poses to our jobs. So AI is certainly the challenge of our age, but it's also an immense opportunity. And just out today, in fact, I heard it on ABC-RN's Breakfast, there's a new report that is on responsible AI. It comes from one of our peak organisations, the Australian Academy of Technological Sciences and Engineering. Top Australian AI experts argue that AI has the potent potential to augment and simplify and improve the way we live our lives. So get hold of that report. It's on their website and it just came out today. And to discuss how we might harness AI for good, let me introduce three leading Monash scholars. We have joining us online, hello Jeff, Professor Jeff Webb, a trailblazing and award-winning researcher from the Department of Data Science and Artificial Intelligence, Monash University, celebrated for a whole lot of work, but especially in bioinformatics and computational biology, amongst other fields. We have Professor Patrick Kwan, a consultant neurologist with Alfred Health, specialising in epilepsy, but he doesn't stop there. He's a clinician researcher in the Department of Neuroscience and co-director of the Monash Institute of Medical Engineering as well, which promotes the commercialisation of engineering solutions for unmet clinical needs. He's a real polymath and I'm really interested to hear what you're up to. And we've got Associate Professor Michelle Lazarus, Director of the Centre of Human Anatomy Education at Monash University and Deputy Director of the Monash Centre for Scholarship in Health Education. She's author of a new book. Check it out. It's called The Uncertainty Effect, How to Survive and Thrive Through the Unexpected. And that very much is our topic today. Let's give them all a warm welcome. I just want to get a bit of a litmus test. Oh, now we should just look at the results here from the online poll. Very likely force for good, 41.89%, possibly 55%, and no way, just just under 3%. So that's our online audience. Thanks for your participation. And we look forward to taking your questions. We've got a roving mic, by the way, in the room, and also we'll be taking some questions online as well. So think away. Look, just to get a sense from each of you, and I'll start with Jeff, from each of your perspectives, how do you see the current buzz around AI? Are you optimistic about what's ahead? Are you excited? Are you a little apprehensive? Jeff Webb, I think I know what your answer's going to be.
Oh, I'm certainly very, very excited, Natasha. It's been an extraordinary year to be an AI researcher. ChatGPT has drawn a lot of attention to the field and has certainly achieved capabilities that I would not have thought over a year ago we would be seeing within the next decade. So it's got an extraordinary ability to comprehend text and do many. Sorry, I'm getting distracted by an echo that I'm getting coming back. So forgive me being distracted in my talking. So extraordinary ability to both comprehend text and to manipulate text in extraordinary ways, and beyond that to also do quite surprising reasoning. So it can solve logic puzzles of a type that I would not have thought would be possible for a general purpose AI system to do anytime soon.
Interesting, Jeff, that you say that, because you've been in the business of AI and data science for 40 years now, so you've always been optimistic about the potential. But for you to say that you're particularly wowed by ChatGPT and the generative AI tools coming online, why do they excite you so much? What good can come from those tools, do you think, if you had to cast a wide net?
So the reason I'm excited is because we've demonstrated that with what's in some ways technically a simple proposition, so simply modelling the ways in which words are used together in language, it's possible to achieve so much. And it's clear that a lot of fairly straightforward tasks, things that maybe we hadn't previously thought were straightforward, like copy editing, many tasks which we previously might have thought required a fairly educated person to do, it's now going to be possible to automate with all the potential positives and negatives that brings along with it.
Indeed. Let's ask what the copy editors think about that. Patrick Kwan, what about you? At this point in time, with the incredible buzz around AI, how are you feeling about what's ahead?
I think I agree with Jeff. By the way, I'm pleased that you did the poll in the beginning, because it sounds like we've got a two-party race here. The little one didn't make a chance, so I'm trying to convince we to think that there is, I think, a lot of potential opportunities it can really do for good. But I think from coming from a user perspective, in addition to the excitement, which I also share because I work a lot with AI researchers, I also have a sense of nervousness. I think I'm nervous in the sense of the expectations from the general public, in the sense the special non-specialists, how we can harness and how we could communicate in a way that really understand the limitations of AI, although we've always been told that things that we thought the AI couldn't do, now it could. But nonetheless, when it applies to the medical field, and I'm not just trying to save my job here, it's also, I think it's very important that we put things in perspective. And so I think I approach this with a sense of responsibilities. I think like new technologies, it's kind of landed upon us in some way, and that's why I feel there's a sense I wanted to learn more. That's why I wanted, one of the motivations for doing the research itself is to, then I can understand the process. I'm starting to learn how to write codes and speak, so I can speak the same language with my AI colleagues as well. But I have no doubt that there is a tremendous support it can help in medical management. And I think going to some of the uncertainties, to help clinicians make better choices, there's a huge potential.
Okay, and I'll get very specific with you because you're about to embark on an incredible clinical trial. Michelle Lazarus, what about you? Where are you positioned in this spectrum of enthusiasm and apprehension?
I think I'll answer as a qualitative researcher. It depends on the context. I think what excites me about it is slightly different than what I've heard from both of our other panelists. It's an opportunity to ask ourselves, who are we as humans? I think for the first time we're asking, what is intellect? What are our capabilities? Which is something that I think hasn't been part of the conversation up to this point. So I'm very excited about that. What are we next to or working with artificial intelligence?
Jeff, you have been doing incredible work. Just give us an example of one of your successful projects. You, for example, have worked in the hospital system, and you were looking at, for example, medical emergency teams. How on earth is AI relevant to a medical emergency team? Because I guess we should say that AI is very much about working with big data and trying to extract the patterns from big data to make sense of them so that they might serve our needs. What are you doing with medical emergency teams, or what did you do with them?
Thanks, Natasha. So you're referring there to work we did a few years back now with the Alfred Hospital, where we took simply their clinical records of all of the medical emergency team call-outs over a 12-month period. So a medical emergency team call-out is triggered when a patient's signs and symptoms go outside pre-specified limits. And then a whole lot of experts drop whatever they're doing and rush to the patient's side, assess what the problem is, and propose the appropriate treatment. And our analysis found that in around a third of the cases, all that was done was rehydration, which didn't seem to call for the level of expertise which was being called to the patient's bedside. So together with the clinicians we were working with, we thought that it was worth exploring that further, and we were able to bring together all of the data about those specific call-outs and see that was indeed quite predictable that would be the outcome in a large number of cases. And what AI was doing here was allowing us to bring together a large amount of data and to look at it and to look for patterns in it in a way that you couldn't otherwise do. So people who are in the midst of the action, it's extremely hard to see the bigger picture. And if you just have all of the information in a spreadsheet, then a complex pattern like that doesn't come out. So anyway, an upshot of this work was that the hospital has changed the medical call-outs protocol, reducing the number of call-outs by more than 25%, and it's estimated saving them about $500,000 per annum, and improving patient outcomes, because they've instead of imposing call-outs for these cases, the nursing staff are empowered to take the treatment, and if somebody's blood pressure is dropping, the sooner you rehydrate them, the better.
Of that research, that really was an impactful example of how AI can interpret data that we mere humans, flesh and bone and blood, really struggle with large scales of data, don't we? And data then becomes opaque and impenetrable to us and not useful to us.
Indeed. So it's not that people couldn't have seen this if they'd gone looking for it. The thing that AI really brought to it was to look for all of the things that could potentially have been interesting and to find which ones were actually there. And there's many millions of potential things which could have been there. This was the one that was, and turned out to be an extremely important one.
Jeff's working with all sorts of large volumes of data, from medical imaging to help with disease diagnosis, to environmental data to predict wildfires, many things. Let me come to Patrick Kwan. So you're an epilepsy clinician. 50 million of us in the world have epilepsy, and I think people would be really surprised that it's really hit and miss. You're really frank and upfront about this, that trying to find the right medication for your patients is really quite a trial and error process. So tell me what you're using AI to do, and about the clinical trial that you're about to embark on, because what's fascinating about this is that you've got a philosopher on board. We will come back to that. But why is AI relevant to you as a clinician dealing with epilepsy?
Yeah. How much time do we have?
A little amount of time.
More time to go home. That's I live and breathe, for epilepsy, trying to improve the outcomes of patients. Such a common disorder is hidden as well. Often there's also misunderstanding. But in the audience, you probably know someone, or you have someone in your family, you know someone has epilepsy. It's actually very common. The problem is a chronic disease as well, so it's long-term treatment. But we have many medications now. In the last 20, 30 years, we have developed, approved 20, 30 new medications. But the problem is that there's no reliable way we can predict which particular medication will work for a particular individual. So the standard so-called evidence-based medicine is you take a bunch of patients, randomize them to 2 arms of treatment, and then you just compare them as a group. You ignore all the personal factors. And that's really frustrating. So when I choose a medication, and the worst still is a number of these medications have very similar effectiveness. They're very similar in how good they are in controlling the seizures. So I say to the patient in front of me, I would say, these are 5 or 6 different medications, and all of them, if you look at the studies, the research, they all seem to work very similarly.
Yeah.
And it boils down to often personal choices, experience, comfort factor by the doctor. We look at other factors as well, obviously, in other conditions, what medications, but these are largely still very qualitative. And so, and often I say to the patient, there's a bit of trial and error. It may take us 2 or 3 goes to find the right medication.
And that's a serious process. If you live with epilepsy, you know that changing medications can be very challenging and very disruptive to your life. It's a big adjustment.
Absolutely.
And so what are you going to do with it? You've already trialled some AI in relation to supporting you as a clinician to make the decisions on your behalf. Now, I'm very interested in this, so tell me about what you're outsourcing in this clinical trial to AI that many people would prefer you to be doing, I suspect.
Well, so we have developed a model using large data sets that have been collected from Australia here and also from around the world as well. Put them together to develop a model that can predict whether someone is going to respond to a range of medications, which one will give them the best chance of working, the medication working for them. So what we're now embarking, that's using retrospective data meaning data collected in registries. And going back to what Jeff said, I think it's fantastic to apply this. And in fact, one of the frustration I have as a clinician, and in a way, it's kind of double standard I see, is that when you have a new drug being developed, the regulators around the world, the US FDA, the TGA, would require you have to do a prospective randomized control trial to prove that it does bring about clinical benefits. So it's all very well to say this algorithm can do the X or Y, Z, but does it really need to lead to clinical benefits? Does it really help the patient? Does it really save lives? Does it really reduce their illnesses? Does it really reduce their hospitalization stay, for example? And for any medications, you will require to do at least 2 trials. Yet, for AI models, for some reason, the regulators and the FDA would be happy to just implement this without doing prospective trials. And that makes me worry as a clinician. So we're very lucky to receive federal funding to embark on a randomized control trial to prospectively test whether applying this model as a decision support tool. So still, as I said, I want to keep my job, so I'm here. The tool supports me, and ultimately it's still the neurologist deciding what to follow.
Okay, so how would it work? Let's just paint the picture for us.
Right.
We can't get the full story, but just put us in the situation where you have a patient before you, you've got this AI system that's analysed a massive data set of other patients and the outcomes that they experienced on the range of epilepsy medications. In that moment, when you're making a decision, how would you use the AI?
So we'll plug in the data into a website or an app, and then click a button, and in less than 30 seconds, it will spit out a recommendation. That's how it works.
Okay, now...
Thanks to the Monash massive computational system here, I will make an advertisement.
All right, so in that moment as a clinician, and I'll come to you on this, Michelle, because you'll have stuff to say about this, because you're educating medical students.
Yep.
In that moment, what if you thought, hang on a tick, I'm not sure about this? Would you doubt your own clinical competence and confidence, or would you go with the AI? What about a junior doctor who was still learning the ropes?
Yeah, I mean, these are real issues. So we'll embed within the team, analyzing not just look at the patient, we actually study the doctors. So these are the questions we'll study. How well would they accept, how acceptable this is to them? How often would they follow or not follow the recommendation? And what make them follow or not follow? And coming back to the collaboration with philosophers, really fortunate to collaborate with a brilliant philosopher at Monash University, and we'll look at the ethical impact of the whole process. So how would the ethical impact, and questions like we've been actually interviewing clinicians and patients, and one of the questions that issues the neurologist came up is to say, would I be de-skilled? Would I lose my skills in choosing medication if the machine is now doing it for me or better than me?
Yeah.
So that's why I said in the beginning that my sense of nervousness, there's a degree of fear, I think quite right as well. And how do we manage and navigate and ultimately bring better outcomes for our patients? So we want best for our patients.
This is so fascinating, isn't it? I'd love to hear your questions for Patrick about this. How do you feel as a patient, and perhaps there's someone who lives with epilepsy in the room, how would you feel about your clinician using a tool in this way to help them make a medical decision? It makes complete sense because you're accessing a sort of body of evidence and then using the AI to interrogate that. Michelle Lazarus,
Yes.
as you sit here thinking about the consequences of AI entering the health sector, what's coming to mind for you in this situation?
I think it goes back to, earlier excitement about this. Who are we as humans? What is the role of a healthcare practitioner or provider? And I think we have to ask ourselves, what is intellect? Is it the tangible, observable facts that you can plug into this computer and get out the recommendation? And there are probably aspects of the healthcare system that we can do that with, where the facts, the observable facts, the data that you could input to machine learning or AI would be accessible. But there's a lot that I think you do as a clinician that's inaccessible to AI. And the challenge becomes what Jeff mentioned before. If the hospital system, the healthcare system, is focused on efficiency and cost, it's going to often prioritize the output that takes 30 seconds over the expensive, potentially, intellect of the healthcare provider. So then in that situation, when you choose to make the decision to either defer to the AI or not, is part of that, this healthcare system that's pushing you to defend your position as a human if you challenge the artificial intelligence. And I think that's interesting. That's where I feel the field needs to go. In addition to studying the AI itself, it's about how the human is going to work with that AI and what the impact is on the healthcare system.
Could you imagine it also causing clinicians to second guess their own clinical judgment?
I feel like in many societies, being objective, we want to be unbiased. We want to treat patients as equal without bias. And AI, if you think about it, it's the pinnacle of that, right? It's so separated from the context. It has no bias because it's not involved in the situation at all. And we tend to, in our society, value that often over our own judgment, our own gut feeling, despite there's some evidence that when a patient's decomping, apparently the numbers, the metrics can, like if a patient's going downhill very quickly, the metrics may not indicate that there's a problem, but nurses' intuition apparently outcompetes all the metrics. So there is something to that, and how do we put that into the algorithm? So I think the AI has power, it has intellect in a way that we can't capture. Both of you have illustrated that. We do not have the power to search and understand the data at the pace that artificial intelligence can do. And we need to have the system that allows the human to ultimately be the final decider and to not question ourselves, because it is so divorced of the situation and the context.
What do we risk losing then in terms of the future of healthcare?
Exactly. I think it's quite significant, because in that case of a patient that's going downhill, all the metrics would tell you to leave it, and it's too late sometimes. And it's that intuition. So we can lose lives.
Or we can intervene
Exactly.
where perhaps it might not be suitable to intervene.
Exactly.
Because the bot tells us to.
Absolutely. But as we heard, there are ways where we can use this to not intervene, as we heard with just providing some fluids, where more intervention would have actually been a bad option. So I think it's about learning. It's not just about developing really high-quality artificial intelligence. It's about helping us as humans work with that and trust ourselves as well. So there's a human-AI interface that's important in the conversation.
We're talking about harnessing AI for good, and to do that we have to recognise the limitations of AI, don't we?
Yep.
And one of the areas of scholarship right now is, well, what are the data sets that we're training these systems on, and what biases are contained within those data sets? If you look at some of the large language models that are extracting data from the internet, you know if you Google the internet is full of bias and racism and sexism and violence. And if these large language models are learning from that corpus of knowledge, that's a bit of a frightening thing, isn't it? What would that mean potentially for biases that are built into these systems?
I think it's like the Disney movie where you talk in the mirror on the wall and it's talking back what the evil witch wants her, mirror, mirror on the wall. That's what AI is. AI isn't doing something we aren't doing. It's just making it wider, more accessible, the bias, more quickly. It's infiltrating it at a faster rate. So I think what it's allowing us to do is shed a mirror on our own society and asking us to challenge our own biases, because that is what's happening. It is not taking data it's not deciding to be biased, it's totally objective.
I'll come back to Jeff in a tick, but Patrick, are these some of the questions that you're grappling with as a clinician as you prepare to deploy AI in the clinic?
Yeah, absolutely. I think the issue about bias is real. That's why for our work, we deliberately go to different healthcare settings, different countries, different culture, include cohorts of patients from different, treated differently, different practices. And yeah, when you get the result back, they're not as clean, as good as you like. They don't get you the 99%, 0.9% accuracy, but that's reality. And I think we need to appreciate the importance of doing that work to ensure what the limitations are in terms of biases. And I think there's still really a long way to go in how to tackle that. And so I think sometimes that's why I said in the beginning when we said, medical AI is a very generic name, and we love a simple yes and no, hands up, hands down. But in fact, there are so many nuances, and to be able to understand where it can help, like it's a self-driving car. I mean, it's great in some sense, but you can't take your hands off the wheels.
Yeah, I mean, it's interesting if you look at the history of randomised clinical trials in medicine. For a long time, women were just excluded. We were just sort of seen as, I don't know, kind of smaller men, really, and that's not the case, of course. But and so, those biases were built into data sets, and so you have to challenge yourself, I guess, to use data sets that represent the full diversity of humanity.
Yeah. And there's never an ideal model. There's never a perfect model, maybe I should say. None of these models are perfect. Right. And we have to understand their limitations.
I want to come to audience questions, but via Jeff Webb. Jeff, you actually started out doing a degree in philosophy, I think, before you became a data scientist and an AI expert all those years ago. And so these are questions that you're actively grappling with too, aren't you? How are you hearing this conversation? What challenges lie ahead if we are to actually try and deploy AI for good?
So the issue of bias is a very interesting one in that it's certainly inherent in these systems, but it's not necessarily insoluble, because everybody involved now is extremely aware of this problem and actively trying to do things about it. So, for example, with ChatGPT, it's built on working out what the most likely response from everything it's seen would be to a given prompt. So if you ask it to talk about a CEO, for example, then just left to its own devices, it's going to assume a middle-aged or older white guy. And the OpenAI people know this and know it's a problem and know that they don't want a system that does this. So they actually intervene in the process. And if you ask it to generate something about a CEO, then on some pre-specified schedule, they actually insert into your query something to specify that it's a female CEO or a black CEO or whatever it might be. So these are very real problems, but they're increasingly well understood, and are certainly far from insoluble.
It's taken the trailblazing efforts of, particularly a lot of black women technologists actually in America to really spearhead discussion about the biases in AI systems. I guess one question I'd have for you, Jeff, is a lot of these systems are very opaque. They're even opaque to the technologists who are designing them sometimes. And furthermore, they're being designed by companies who are developing them in a commercial in confidence context. So that's another level of opaqueness, isn't it? How can we build transparency into AI so that we can harness its benefits?
So this is another extremely important issue. So for some purposes, it doesn't really matter if we understand how a system is reaching the conclusions that it's reaching. If we're asking ChatGPT to write poems, probably doesn't matter whether we really understand the basis on which it writes those poems. But if we're asking it to give us recommendations for epilepsy drugs, then it absolutely matters that we understand whether the basis on which it's making its recommendations are grounded in some reality, or whether it's just making stuff up, which is one of the problems with these systems. They've been trained to answer any question they're given, and they always generate an answer, and they generate it in a tone which is entirely convincing, but it's not necessarily grounded in reality at all. I'd like to, if I can, just derail the conversation, take it back to what we were talking about a few minutes ago, which is about using AI systems to help experts make decisions. And one of the easy mistakes to make in that context is to think that the AI system should be used to give its own recommendation, for example, of what the drug is that a patient should be given. But I think it's important to understand that AI systems have access to very different information to what clinicians have access to. So the clinicians are going to have access to the human factors in a way that an AI system is not going to be able to in the foreseeable future. And they're going to be able to understand what the practical impact on a patient and their family, friends, etc., is going to be of a particular course of treatment. So what the ideal use of AI is in these very high value, high cost, important decision-making contexts, I believe, is rather than making recommendations, is to put further information in the clinician's hand, or the expert, if it's a non-clinical problem, of a type that they would not have ready access to themselves. So it's much better, it's much more useful. So I don't have much interest in creating AI systems that are replicas of humans, because we've already got billions of intelligent things, beings that have that form of intelligence, and we don't need more of them. What I'm interested in is creating systems that are able to do things that humans can't readily do, and so therefore can be used to augment our capabilities to tackle really hard problems.
Let's thank our wonderful speakers today. Jeff Webb joining us online, who was feeling a bit crook today, so thanks for being here. Yes, Jeff just got back from overseas and he's had a nasty lurgy. Doesn't think it's COVID, but it was best that he stayed put. So thanks for getting out of the sick bed for us, Jeff. Really appreciate that. Professor Patrick Kwan and Associate Professor Michelle Lazarus. Well done. Thank you so much for being here, and here's the Vice-Chancellor to share some departing words. And thank you so much for joining us online. It's wonderful to have the big Monash diaspora as part of this conversation.
Thank you so much. Thank you, Natasha, Jeff, Patrick, and Michelle for that wonderful and insightful panel discussion. I've really enjoyed hearing it. It's clear that we're talking about extraordinarily powerful tools, but we're also talking about humans and our extraordinary capacity for creativity, for clinical judgment, as we've discussed tonight, and for evaluation of evidence as AI presents it to us. So I'd like to conclude the formalities of this evening's event, and that concludes the 2023 Challenges of the Age series. Thank you once again for your attendance tonight. It's much appreciated. Please continue to stay connected with Monash. We value you as part of our community and hope that you value us as being part of your lives. So please stay tuned for news of its Challenges of the Age series return in 2024. Take home safely. Good night.